Hey guys, it's the British version of me going over an example video for this particular lesson. So you can recall that we learned about three different cases. In the most common case, when we're solving equations with only one variable, so one variable meaning there's only an r in this equation, what we get normally is just one solution. So we're going to go ahead and use the graphing calculator to find that one solution by taking the left expression, the left expression and the right expression and graphing two different lines and then finding where those two lines intersect. So here's the left expression. I'm typing it in now. Remember, we're using a x and y plane, so we need to replace the r with an x. So I'm x plus 37. There we go there. And we've got plus 26x. Cannot put the r. If you put the r, you joke. Oh, put it in parentheses. I must close the parentheses. It's very important that they're closed. Then we put that in there, just like that. So you can see here I've just typed in the expression on the left side of the equal sign, and now I'm going to do the same for the expression on the right, making sure again to replace the r with an x. Typed it in, verified. Now there should be two lines on this graph, so I'm going to go ahead and zoom out here. So you can see there's two lines. There's the yellow line, I can go ahead and close that, and the black line, so you can close them. What we're looking for is where they intersect, so you can kind of move the graph around, play with the graph, get familiar with it, and we can see that the two lines are intersecting right here, and Desmos is a fantastic calculator, has given us the solution. So it gives us this value, negative 19, and it gives us another number here. This number is 28. So essentially what that is when I plug in negative 19 for all of the r's, what is going to happen is we're going to get something that says 28 equals 28. That is true, so we know that the x value here is our solution. So we say r equals negative 19. Special case number 2. So this is an example where we do not have a solution, so what I'm going to go ahead and do is going to type in the value or the expression on the left, and I'm going to replace the a obviously with an x. So it makes the most sense if we're using an x and y plane. Now I can type in the expression on the right, again making sure to replace the a with an x. Now what I've got here is two lines. I can't see the two lines, so I'm going to go back to the default zoom, and now I've got two lines and I'm looking for where they intersect. So I'm zooming out, and eventually those two lines become one line. So I've zoomed out way too far. Now I'm just going to kind of drag up and down, and it's quite clear now why this is a no solution example. The two lines are running parallel. So what that means essentially is this: when the blue line when the blue line goes up, the red line is going up by the same amount. They have the same slope, so they're never going to intersect. So the reason why they're never going to intersect is because there's no value for a that makes the left side of the equal sign the same as the right side. So we'll never get a solution here, so we can go ahead and say a equals no solution, just like this. Perfect. Alright, so now for the third and final case, and this is infinite solutions. So essentially that means every value for the variable that we plug in is going to result in the same number on both sides of the equal sign, so equivalent expressions. So let's go ahead and see what that looks like when we type in the line. So I've got negative 82 plus 35b, but I'm putting in x again, remember. Now I've got to type in the expression on the right, that 5 times that 7x, obviously not the b, and then we put in the 16, close the set of parentheses, and we've got a minus 2 there. So you can see here, I've typed in the two lines, and they're both there. So I'm going to go ahead and zoom out. So I'm zooming very far out, and I'm not seeing the lines, and I'm getting to 2000 and negative 1500 and up to 10,000 there. Actually, that's 15,000. Sorry, I've read the units wrong. So I cannot see both of the lines. So what does that mean there? Well, think about it for a second. If we are going over an example where no matter what number or value we plug in for the variable, it's going to result in a true statement. That means that lines must be intersecting at every single x value, and that is the case here, because you can see I take away that line, I'm only looking at that line there, and I take away this line, I put this line back, can't really see, is that a green line, hopefully, and there we've got the blue line. So you can see that the two lines are on top of each other, so this would be a situation where x equals all real numbers, or sorry, b equals all real numbers. Every single number is a part of this solution.